Hello, this is Pat. In this topic video, we're going to look at the law of large numbers and give a short example of it using coin tosses. Basically, the law of large numbers, and I will have this printed out in HTML so you can link to it as well from the topic. And you can also go to this Wikipedia entry. The definition is basically with probability theory. This theorem describes the result of performing the same experiment a large number of times. So the more we can do the experiment, the more we should see the expected result. And the expected result, according to the law, is the average of the results obtained from a large number of trials should be close to the expected value. And it will tend to become closer as more trials are performed. So basically, you can do this quite easily if you had a coin and a notepad and a pencil. But after about 100 times, you may start getting a little bit bored conducting the experiment. With a computer, we can emulate that or recreate that and make it very easy to do millions of turns if we chose to, or millions of tosses. So in this case, I'll include the code itself so you can take it and start with it, and then you can kind of create what you choose from it. In our case here, it'll be followed. I variabilized a few of the items. I'll cover them, and then we'll go through an example of it, and I'll run the test a few times. So basically, I have a number, so a large N. I'm going to do 10,000 in this particular case. This is just what it was when I saved it. I did 10,000 flips of the coin. My output, I'm going to create a output in the console so you can actually see how the first 10 or 20 or 30, you can set this to whatever you want. You can actually see the running average as we go through, or the running mean. So it'll be kind of interesting to see as it grows, but I'll show that once. It'll make more sense. But all this doesn't really affect your overall number. It just gives you like a running tally along the way. I have a seed set just so my experiment will always look the same. You know, if I was running it in a class, I would get the same distribution, but you would want to comment that out when you're running it multiple times because you want some randomness to this. Now now that I have those variables set and I would have seed commented out, we're going to set 3 variables just to simulate the coin flip. So in our case here, we're going to have X, and what X is going to store is the flips is either 0 or 1. So I guess you could say head 0, 1 tail, whichever you choose. And the number of flips will be set by the value of N. Right? So that's up top of 10,000 to start, but we'll change those and you'll see how easy that is. The S is just going to keep a running total of occurrences, and that will be, in other words, I'm scoring every time it shows a 1. So what's the total amount of 1 in those particular tosses, each iteration? And then we're going to keep the average, and instead of using anything fancy, I just called it r.average, and I literally just did the amount of times it was 1 by every one in that vector, 1, 2, however many it is, in this case 10,000. So very easy piece of code using all basic R in this case, all the base package. Then we're going to assign those running statistics to the rstats variable. And the reason I do that is this is where I keep that run. Right now I'm only keeping 10, so I can see the 10 that come back in this particular experiment. And notice and this is a running average, so by the 10th one, I'm at 0.6. Of course, we're going to expect it would be closer to 0.5. But with only 10 flips of the coin, you can see we got a tail, a head, tail, tail, tail. So there, it's a little bit higher than half. And then a head, a tail again, 2 more heads and a tail. So we're actually well above. We're at 60% instead of what we'd expect, the 50%. You know, it's a heads or tail, 50-50, right? But at only 10 observations, we are seeing a little bit higher than we would expect, right? So next we'll come on down and we'll chart it as well. So I put together a simple chart. I use this SciPy function just to keep these numbers instead of looking like my observations. I don't want them to be scientific notation, and that prompts it or hints at it to do that. Then I create this plot chart, and then I put a line in. Obviously, I just did a little vector of 50-50 because tossing a coin is 50-50. So it's just the red line. So that's where we'd expect we'd get closer to. And notice at 10,000, I was getting quite a bit closer. At some point, I was touching relatively close, etc. We'll do some observations live and we'll be able to see it. Now when I publish this up to, and then I do a overall average so I can look at the number, and notice we expect it to be close to 0.5 and it was actually 0.5047. So even at 10,000 I was well within the statistical significance and well within that 50 percentile. So you can see law of large numbers. So as we had a lesser amount of observations, it wasn't that close to 50%. Then it went over the line and actually went above it a little bit, but then it started to level out and started getting closer and closer to the line as we went. So we'll play with that as we go. Now, just as a note for when I publish this to HTML, what you can do is you can take these observations within the gray. They should be able to copy and paste and keep their formatting for R as simple text. So you can kind of create your base by anything in gray. You can just copy that, paste it in, and then from there you can edit it and do what you want. Maybe you want to do a pretty ggplot2 chart or whatever it may happen to be. That's fine, you can do that. So that'll give you an idea of what you'll see. It'll look just like this. It'll just be an HTML, and I'll provide the link for it. Now here's the actual code that I was using, and it's the same exact code as the HTML page that we were just looking at. The only difference is here I can run it live. Notice everything else I commented out we don't really need. I commented out the sets and the set seed. Oh, I'm sorry, my set my directory, my get my directory. I just checked my working directory, and I commented out the seed because we'll go ahead and do this live now. So what I'm going to do is I'm just going to go ahead and select the entire thing. Or actually, I'll walk through it the first time, and we'll do one that's kind of silly the first time out. We'll just flip the coin 10 times. Or actually, let's just do this. I'm going to say 15 times. We're going to observe in the console 10 of those. That's the one I told you about where we want to look at how is it progressing in the first 10, and then we'll build everything out just like we discussed before. So I'll run the first one. I'm assigning n the value 15. So that's the amount of flips we're going to do. You could do that quite easily with a Looney or a Toonie and a notepad, like I said, but we'll crank these up as we go. I want to see 10 of those observations in the console. That'll make sense in a second. And now I'm going to pass in my samples for X. So now you can see I've rolled a heads, a tail, a bunch of heads, a couple tails. So even though they're small, you can actually see them here in the values. Now I'm going to do my cumulative sum. And the reason I'm doing that is I want to see through those 15 how many times did I get head. Now I'm going to do my running average. And now my running average, notice I'm starting to see each one. The first time out it was 0 because they were both heads. Then came a half because one head, one tail. So this is a cumulative or running average going across. So you can see it quite well actually in this one. So you can see that's what's occurring here with the running average. It's just keeping it as it goes through each flip. Again, law of large numbers says the more I go, the closer it'll get to the 0.5, which is the expected of the population. Now I'm going to pass into our stats. All I'm doing here is I'm taking these three, I'm binding them together, nothing fancy here, and then just rounding them. So I'll only end up with 3 digits after the decimal instead of a bunch. And then I can print the R stats. So here are the 10. So that's where this 10 comes into play. I'm seeing 10 of them here. I can push that up, and you'll see what's happening is over the first 10 I've ended or resulted with 0.40. So I'm a good 0.1 below what I expect, which is 0.5, but it's because I've had a large amount of zeros in there. And you can see my S score, which is how many times a 1 occurs, keeps moving up as a 1 occurs in the X. So every time a tails is flipped, it adds 1. So the first time it was 1, second time it went to 2. Notice it stayed at 2 for all these heads. Another tail went a 3, another tail went a 4. And then we do that simple math. So it's very simple math, but a very easy way to explain to someone who maybe doesn't really have played with large numbers in this particular case to see how the coin toss would go. Okay, now I just want to do the plot like you'd expect. We'll move it over so we can just see our plot a little bit better. There's lots of room here. So here in my plot, you'll see that's the actual line. I'm going to put in the red line, and it's pretty crazy right now because I did a very tight range here, so it's going to look like pretty wild when across only 15 observations. Then when I look, we'll see the final one. I see my random average overall, a 0.533, but that's still, it's gotten close because it hit a lot of tails at the end, but it's still not exactly where I would expect it to be. Now, that said, what we want to do is we want to change this a little bit. And whenever there's just two results, like a heads, tails, a lot of times I've heard people say, not 130, But 30 seems to be the observations where we start to see things. I'm just going to hit all and run it. 30 is where we start to see things, kind of our 30 binary observations. So it's got to be yes or no, 1 or 0, in this case heads or tails. At around 30, and just by coincidence, I think it did hit. There it is, 0.5. I'll run it again. They usually say you'll get fairly close. Notice here, even at 30, it was still not so close. It was still a tenth off. There was a lot of heads rolled, very few tails, and not enough to make it back to 50 in this case. So you can see the more I run this with randomness, this one landed right back at 50. But again, notice it's pretty varied along the way. So what we can do is, from now, you can actually play with this and just keep changing them. If you want to do, let's look at 30 observations in the chart so you can look at them down here. I'm going to do a Control L to clean my console. And I'm going to now run, I'm going to select all and run it. And notice now I'm starting to see, that was kind of interesting. It ended up being a 0.46, so a little bit closer. And if you come up here to the table, notice you can see the running average. As you're at the smaller amounts, or the initial observations, we're at 100% in the first 4. So it took a while for it to get closer to 0.5. And notice then it starts staying in the 0.5s. You don't see it really leave the 0.5s after that. Notice very wide variance here from 0.0, 0.8, 0.6. But once you start seeing the 0.5s, it pretty much starts to stay in that realm. And of course, the lovely thing about a computer, 1, 2, 3, so that'll be a million. I'd still be looking at the first 30 in my table. I'm going to do a Control L here. Now when I run that, and it'll probably take a couple seconds for this one to draw out the plot. It's just got to go through a million. Here we go. Notice now when you see the observation, I'll zoom it in a little bit. Notice this is where you're seeing this tail is going to be a little bit more, I shouldn't call it a tail because there's no bell curve here, but this is where you're going to see that there's a lot of variance in the first rolls. But notice once it starts to tighten up and you're starting to get a lot of observations, notice the actual observations line hugs the red line, which is the 50-50, almost 1-to-1. So it'll give you an idea how to play with this and how to explain. If someone asks what's the law of large averages, coin tosses are, I find, the easiest. And also if you want to show them some of the earlier observations, this is a nice way to do it. Just include it in your code. So you can see here, notice everything. Wow, that was a pretty strange start. Everything was like a 0, 0, 3s, 3. They didn't even come into the 5s anywhere in the first 30. Kind of an interesting one. Came up to a 0.429, but they never came back into the 5. So it'll give you an idea, though, once you start getting into the 5s, you get 2 or 3 in a row, they tend to stay there. And again, that's another way to show them that law of large numbers.